So the drivers are there now, whether it be planning conditions, whether it be financial savings. We're going to be installing more solar PV on our roofs, and we really should be. But there are a number of design considerations we need to think about. We are biased, I will give you that, but the first thing that we look at when we're looking at putting a solar PV system on any roof is what is the roof? What are the roof existing or new roof conditions that we're putting it onto? If you're retrofitting solar to an existing roof, the best time to do it is when the building is being re-roofed. So if your building looks like this, your roof looks like this, and your client is saying to you, well, you know, we've got a pot of money to spend on solar, don't really want to spend anything on the roof, but let's get something up there. If it's not leaking now, it definitely will be by the time that you've installed a couple of tons of ballasted solar. I am not by any stretch saying that you shouldn't retrofit solar to existing buildings. But the key thing is to ensure that you're not going to, one, invalidate any roof warranties, or two, do any damage to that roof or cause any leaks. So making sure that the warranty provider is consulted is really important. And there is often a balance to be made by, should you overlay it and extend the roof warranty so that it matches the solar PV lifespan? Or if it's 5 years old and you've got a really good warranty in place, then you can just go back to it. But it's a conversation that should be had. The second image there is about membrane durability, and it's largely relating to new build, and it's about value engineering. So very often, different roof membranes will have different friction coefficients. They will have different levels of durability. The protection and the mounting system that you put in will vary depending on the waterproofing system. So I guess the key message there is, if you're putting a solar PV system on a building that's designed to last 35 years, but you put a roof system up that only has a 10-year warranty, is that value for money? Is that the right decision to be made? Equally, if you're value engineering, or if a system is being value engineered, ensure that the solar PV provider knows what the new roof system is going to be. And the final one there, from a roof perspective, structural stability. Most of the time, systems on flat roofs are ballasted. You are adding a load to that roof, so ensuring that there's a structural engineer involved and they've okayed it, they've ensured that it's not going to have any negative impact on the structure is absolutely paramount. So we've established that the roof's okay to put our solar on. There's a number of different ways that we can fix that solar to the roof. Historically, there were a lot of systems in the market that were installed through mechanically anchoring. These days, not so much. We would only tend to install mechanically anchored systems as a market, as an industry, where either you're on something like a tower block, on a pitched roof, or on a coastal application where you've got really high wind loads. If you do have to mechanically fix, then a bespoke fixing, this is a Nicholson IFP. Generally, they'd be provided with a Bauder waterproofing membrane, and that would be fixed down and then welded in. Mechanically fixed systems are more expensive, they're more time consuming. So as an industry, they tend to be avoided, but if you've got any of the criteria I just mentioned, then you will have to. We also try and avoid any penetrations through flat roofs. So where you can avoid mechanically fixing, generally that's going to be beneficial. So most of the systems installed on flat roofs will be ballasted. And there are lots of different options for ballasted systems. They are developing all the time, and they're generally these days really very good. Usually you'd be looking at about 25 to 30 kilos a square meter for a ballasted system. The key things I would highlight, if you're ballasting solar to an existing flat roof or to a new build flat roof, are that there must be a sacrificial layer between anywhere where you have the mounting system connecting to the roof. In this scenario here, this is a really good, cheap and cheerful solar PV mounting system, but these metal plates will heat up to 80 degrees, potentially quite regularly during the summer. So ensuring that there's a sacrificial layer wherever they're coming into contact with the roof is really important. Second item for ballasted systems, as they get more aerodynamic, as they get denser, to get more on the roof, like this system here. Really good low ballast system, but you're burying the roof. And ultimately, it comes back to that warranty element that I mentioned a moment ago. If you're installing these systems, it's somebody in that process needs to ensure that the warranty provider for the roof is consulted, and that it's not going to have any negative impact on the roof. Once that system is in place, you can't do thermal surveys, you can't do a visual survey of the roof. Finding any leaks can be really problematic. And I'll come back to the warranty clauses at the end of the webinar, but just ensuring that there's no negative impact on the roof warranty is really important. Few quick design considerations regarding location and layouts of solar. Historically, the design tools, particularly for new build, things like IES, would have a drop-down box that would say, right, most efficient angle of panel, most efficient orientation of panel, and that's how it would design it as far as the thermal model is concerned. So you'd end up with your thermal model saying that you've got 30-degree panels due south. Actually, on flat roofs, it's very rare that we install solar in that kind of orientation. At 10 to 15 degrees, you've got significantly lower wind loads. You're not putting a sail on the roof effectively, so you don't need to mechanically fix. You need a lot less ballast. As importantly, you can get a lot more solar on the roof. So what you lose in efficiency, which might be 1, 2, maybe 3% max, you gain by getting a significantly larger amount of solar on your roof space. So you will almost never these days see solar PV systems installed at 30 degrees. Likewise, the thermal models will always push the system so it's orientated due south. If you've got a very large roof, and we've got the luxury of doing that, then that's exactly what we will do. We will always try and orientate the panels as close to south as possible to provide the maximum generation and return on investment. But with most buildings, we don't have that luxury. And this is an example of a scheme we did in London. The planning conditions were that we had to just maximize the amount of solar on the roof. It's part of the London plan. And so we did this design for the client. So the panels weren't orientated due south, but they would probably get about 20% more solar panels on the roof than if we'd orientated them across the roof to face due south. Actually, what the client ended up going for was this system. Now, some of these panels are actually facing northeast, which is not what we would recommend. They still work in that scenario, but probably only at about 60% of the efficiency of the panels that are facing southwest. So, but ultimately, this orientation would be what we would generally be looking at. So orientating the panels as close to south as possible. We do a lot of east-west systems these days where you concertina the panels across the roof, and that's so that you can get more panels on the roof, but also we get a lower bell curve. So you get more generation in the morning, more generation in the evening, and on some projects, then you'll get more self-consumption. Wind load is really, really important. The impact of wind load on a solar panel in the corner zone here will be about 7 times that of the wind load in the field zone in the center of the roof. So as a general rule of thumb, we try and avoid the corner zones, edge zones of a roof. As planning conditions and the financials that I mentioned earlier get more important, we are now gone are the days where we're installing 10 solar panels on a 4,000 square meter roof. We are generally filling every square inch of roof space that we've got, and that is putting pressure on the designers to push panels into corners and edge zones. As a rule of thumb, you're going to have some kind of safe access. So you're going to have either an edge restraint, handrail, or you're going to have a man-safe fall arrest type system. Either way, that will stop you going too close to the edge of the roof, because that will be in that zone. But as a general rule of thumb, please avoid designing solar panels into those areas. As a very minimum, we would always assume a meter around the edge of the roof. Last point on designing solar into the roofs is shade. So hopefully you're not too surprised to hear that that solar doesn't work when the sun's not shining. It also is significantly impacted by shade. So if you have or solar panels, I should say, are installed in what's called strings. You have a string of panels, usually around 18, that act as one power unit. Now, I must say that the panel technology and inverter technology is getting better all the time. So the impacts of partial shading are reducing all the time. But again, if you have the option, avoid putting solar panels in shade. So if you're doing a retrofit application, Martin or I will go out and do a survey for you. We'll tell you where the shade is and we'll avoid putting solar panels there. In new build, it's much harder. This is actually the M&E, the headquarters of one of the UK's main M&E consultants. This was the roof plan we were given, and this is actually what was on site. So unless we're given that information, we can't design based on it. And in this scenario, this system will probably only work at about 60 to 70% of what it was originally projected to do. So we're avoiding shade wherever possible. So maintenance. As with any flat roof, solar PV requires maintenance. We start with monitoring the system. So all of the inverters that we provide that are available in the market these days will have some form of built-in remote monitoring. And that can take a number of forms, but generally it's a web-based monitoring system. There's a system here called Solar Edge, which is a really, really great solution. And that has a power optimizer in the back behind each panel. So each panel works individually. So it has shade benefits as well. But the beauty of Solar Edge is that you can log in, you can see what each panel is producing that day, week, month, year in its lifetime. It also gives you alerts. So if you have a problem with, say, in this case, this is a project that we did in the Midlands in the UK. This is the roof. This is a schematic of it on the online portal. We can see that inverter number 2 isn't producing what it's supposed to. And in this case, the Solar Edge engineers could just log in, do a firmware update, and that inverter was working again without anybody going to site. But we identified that there were a couple of optimizers that weren't working correctly, and they could send an engineer out to site to carry out maintenance and go specifically to those panels. So maintenance is really quick and really straightforward, and the system is down for a very, very short period of time. So monitoring is really important. We can be proactive with our maintenance, but we still need to maintain these systems, and access for maintenance is vital. So there is so much going wrong in this image, it's hard to know where to start. But the first thing would be, how are you getting access on that roof to inspect your outlets? How are you inspecting your solar PV system? How are you inspecting your roof lights? Again, access around the perimeter, really important. Safe access. If you need a man safe or a handrail, that should be in place. You are going to have to access this roof. And that maintenance takes a number of forms. If you are next to the Hammersmith flyover in the middle of London at 10-degree panel face, then the chances are you'll have to maintain these panels and clean these panels every 3-5 years. If you're in Galway near the coast at 30 degrees, the chances are that you'll never have to clean those panels, or you may only have to clean them 2 or 3 times in their lifetime. But it will depend on the outputs. And again, that's where the remote monitoring comes in, because often you can be proactive. You can see if there's degradation and it's not producing what it's supposed to, and you can identify whether that's because they need to be cleaned. We then require not so much maintenance, but an inspection of the roof side, so the mounting system or the connectors, every 3 years, and then maintenance of the actual inverter and electrical items. DC isolators should be on an annual basis. I'll come back to that bit a bit later on as well. Solar panels, how are we doing for time? So solar PV panels, part of the reason I love working in solar is because the technologies are moving all the time. There's always something new to learn. largely, the panels that we are installing are silicon crystalline panels. So upwards of 95% of the European market will be silicon crystalline panels. They are efficient, they're cheap, they're easy to get hold of. They very, very rarely go wrong. So for those reasons, this is the current lead technology. And it just in amongst silicon crystalline cells, we've seen a move from a 270 watt panel back in 2018. Now we're looking at 430 watt panels for more or less the same panel face. So the efficiency and the technology is moving all the time. And in amongst that, you've got lots of different options. So there's lots of different manufacturers. The panels very much look the same, even for somebody like myself who is involved with this day in, day out. If I go onto the roof and just look at the front of a solar panel, I would find it very hard to identify which manufacturers those panels had come from. We partner with two manufacturers. JA Solar are one of the world's leading suppliers of panels. They're a Chinese manufacturer. They're very, very good quality, and they're cost effective. They generally have a 12-year warranty. The alternative to that is something like this solar watt panel on the left. That's a glass panel with a 30-year warranty, and slightly higher efficiency. Also has an A rating from a fire perspective. So it depends on what your client and what you're looking for, but ultimately these two, there are a number of options out there depending on the project. Inverter location is really important, because if anything's going to go wrong with a solar PV system, it is generally the inverter. So inverters should be somewhere where they're easy to access, to maintain and inspect. You can put them on the roof. They are IP65 rated. So if you have very little space internally, or if you just have a preference to put them on the roof, that's absolutely fine. They should be out of direct sunlight, because they will derate over a certain temperature. They should also have a fire backing behind them if they're fixed to a wall, or a fireproof board underneath them. I personally prefer to put them internally in a plant room where all the other M&E kit will be, generally because out of sight is out of mind. And if they're in the plant room, it's far more likely that they will get inspected and they'll get maintained. If they've got a red flashing light on the front, somebody will do something about it.